Okay, so picking up pretty much right where we left off on the last one. Just clean up this code a little bit, but um, uh, let's jump over here. So let's follow a little bit better pattern here of putting these in here so that we can see what we're doing. Um, so we have a flower, this flower type image that we were kind of like working with, but let's just let's change that a little bit. So we got radial now. We're saving one out called radial, and what that looks like is this. And so I want to look a little bit more at ways to mix things together. There's some other ways to look at it. I'm going to call this drip. The distance formula that we were using before. If we take the distance and we do an output like adjustment and take the value or the output, whatever, value, whatever we want to call it. If we take that value and we do kind of like we were doing right above, and we take like a sine wave of that output value. Whoops. Just hitting tab all the time, filling everything in. Kind of normalize it to a 0 to 1 range. So we're going to adjust that and call it drip. Hey, that's why, because I called it V, so let's use V. Sorry, I'm like all over here. That's weird. Okay, anyway, you can choose not to watch this if you don't want to. This is kind of not probably interesting for most people. But anyway, let's see. We'll just save that, run it, and we're going to end up with a couple files. So we got the radial, and we got drip, but drip's not working so well. I was expecting more ripples, more like ripples in a pond. So let's try to increase the frequency, like the value that's being fed into that sine wave function. Let's see if cranking that up a little bit is going to give us a little bit more of a drip or a ripples. Yeah, that kind of works. So we got that, and then let's create a new one called mix, and we'll do radial, and we'll mix add drip. That's pretty straightforward, and instead of typing a lot of code, I'm going to just jump all over the place here and copy and paste stuff. This is our mix. Okay, so let's output our mix and see what that looks like. Okay, here is the mix. So we combine the radial with the, so let's remember what we're dealing with. We got radial and we got the drip pattern, and we add them together, we get that. So okay, that's kind of cool. Let's experiment a little bit with the different types of mixing that we can do. So now I'm going to go back over here, and so yes, you combine the radial and that, and you subtract, you get this. I mean, it's pretty much like the inverted version of what we were just looking at, but yeah, it's kind of interesting. And we did kind of multiply before, and that didn't look too interesting. But if we do something else like maximum, which is a little bit different logic, it's like take the highest from either one of them. Don't really mix them, but choose one that is, choose one that's the highest. So between this and this, if you get the maximum, you get this. So that's kind of cool. It's got some interesting detail there. And then you can, go around and tweak a bunch of stuff. So let's say we crank up the frequency of those ripples and we go back. Now our drips look like this and our mix looks like that. So it's kind of weird how like the ripples like blend in or disappear into the other into the radial waves, but the radial waves we could crank those up too and just run something out there. And so then we crank up the frequency of the radial waves to that, and so we're dealing with something more like that, which I mean we're getting somewhere. It's still a little hard to like look at some of this stuff, but we might be able to make some interesting details with some of it. And the code's not terribly complex. We're kind of saying, take this radial, do a sine wave, take this distance, do a sine wave, and this mix is pretty straightforward. We're just going to mix the radial with the drip. So this is probably a better way for us to write it instead of smashing it all together in one line and just keeping it running on. Kind of dump it out to separate files, and we'll get hopefully a better understanding for what's going on in some of these. Let's see what other types of mixes that we have in there. We could try multiply, I guess. I don't know if that'll be that interesting though. So we take this, multiply this, we get this. It's not bad, but kind of like the sharp edges that we were getting by doing like the maximum. We could try minimum just to kind of see how that compares. So we'll jump back here. Sorry, I just have to change like files in order to get Paint to refresh the image that it had loaded. And so that's kind of cool. I mean, it's really just the inverse. So like if I were to take this and like invert the output, I'm pretty sure we'd end up with the same thing that we had from the maximum. Yes, that's this. So it looks the same. I mean, basically, if we do the minimum or we invert the maximum, it's kind of the same pattern, I guess. If you look, the waves would probably be, be troughs versus peaks. It'd be kind of turned, whatever, a few degrees in one direction. I'm probably not making much sense, but I'm trying to understand it myself, look at it, visualize it, and picture what's going on with the math there. And I think what happens pretty quick too is this can kind of run away from us as far as understanding exactly what's going on. And so in my next video, I think I'm going to get into something that is really hard to visualize with these equations, and that's when we kind of start displacing the location we're grabbing the value from, kind of like offsetting where we get the value from. But yeah, I'm not going to explain that now. I'm going to do that in my next video. Thanks for watching though.